Factoring cubes. There's two main types of expressions we're going to be factoring. Sum of two cubes and the difference of two cubes. Before we do anything, you need to recognize what numbers are cubes. If you were to take 2 cubed, you would get 8. So 8's a cube of 2. 3 cubed would be 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. And so on, so on, so on. And so, these are the kind of numbers that you want to look at or try to find. So just be prepared. Once you see these kinds of numbers and you see x cubes and y cubes, then you know that you're going to factor using these special patterns. These are the patterns, these are formulas that we're going to use for cubes. Now if you take a good look at these, what you'll notice is that the first expression, the first factor, is the same as what you have in the original problem, but without the cubes. Now you'll notice that these are the same also, except for the sign. The way I was taught back in the day is, each of these only has one minus sign. Use it up as soon as you can. So with this one, the sum of cubes, you have to use the same expression without the cubes in the first factor. Therefore, use it up as soon as you can, which is right there. Now with this one, the difference of two cubes, once you write the same thing in the first factor without the cubes, you've already used up your minus sign. No more minus signs. And the way to think of this, another way to think of it is, this is the same as that without the cubes. This is square multiply square. Because if you look, this x squared is the same as that squared. Xy is multiplied together, so it's the same as x times y. Then y squared is just the same as that squared. Square multiply square. Here's the thing, when you multiply, change the sign. That's another way to think about it. Probably doesn't make any sense, but here we go. We're going to do some examples and they will. These perfect cube numbers, that's what I was listing over here. They never stop. This is what I was listing. So let's do a few. X cubed plus 8. As soon as you see that cube, you're thinking, is 8 a cube also? It just so happens that it is. It's a cube of 2. That's actually the hardest part. Because once you have that, you can use this pattern right here. Throw in and substitute the x with the x and 2 for the y, and take it from there. I personally like to do it like this. I know that my first factor, which is a short one, and my second one is a long one. The first one is the same as what we have here without the cubes, x plus 2. And here's all the pattern is. Square. So when you square the x, you get x squared. Multiply. I'm going to abbreviate it. Take x times 2 and you get 2x. You actually get a positive 2x. Change the sign. And then square again. Square the 2, which gives you a positive 4. Square, multiply, square. You're done. This would never factor, by the way. Now let's do this one. We see that x cubed, but we also see a 125. Is that one of our perfect cube numbers? It definitely is. It's a cube of 5. So our first factor is x minus 5. The same as that without the cubes. Then we're going to square, multiply, square. Square the x, you get x squared, multiply. X times negative 5 is negative 5x. Change the sign. And then square. And negative 5 times negative 5 is a positive 25. Square, multiply, square. You're done. Now look at this one. We see all kinds of cubes roaming around. So, 343, is that one of our perfect cubes? It most definitely is. It's a cube of 7. So not only is that 7 and the x being cubed, they're both being cubed. So you can write it like this. See the 1,000? It just so happens that 1,000 is one of our numbers because it's the same as 10 cubed. So 1,000 is the same as 10 cubed, but the y is also being cubed, so we'll write it as 10y cubed. Watch this. Small, large. What's being cubed? Here's the way I actually like to do it. I actually like to bypass this step. What's being cubed here? A 7. What else? The x. What's the sign you see? A plus. What's being cubed there? A 10. What else? The y. then from there, square, multiply, square. Take the 7x and square it. Don't square just the x, square the 7x. And you get 49x squared. Now take the 7x times the 10y, and you're going to get 70xy. But it's a positive, we change the sign here. So it's a negative. And then we're going to take the 10y, square it, we're going to get, let's mark that out because I'm running out of space, we're going to get a positive 100y squared. Square, double square. Just to make sure, I want to do one more. Let's just make one up. You want to? Let's do 216, and I don't like that one. Let's just do, I'm trying to find one that doesn't have anything in common. Let's just do 64x cubed plus 729y cubed. I want to make sure 729 is one of those. And it is. Now here's the way I do it. I see cubes everywhere. I know that 64 is a cube of 4. The x is being cubed. The sign is a positive. 729 is actually a cube of 9. And then the y is also being cubed. You may be wondering about 9. 9 times 9 is 81. 81 times 9 is 729. But once I get that, I'm actually done with the hard stuff. Because now I'm going to take that 4x, I'm going to square it. Get 16x squared. I'm going to take 4x times 9y and get 36xy. Change the sign because it was a positive. We're going to make it a negative. Now we're going to take the 9y and square it. 9 times 9 is 81. Y times y is y squared. And we're done. That's all you're doing.